Different types of probability sampling. Probability sampling methods are techniques where each member of the population has a known, non-zero chance of being selected for the sample. This approach is essential when the research goal is to make generalizable inferences about the entire population, as it reduces selection bias and improves the reliability and validity of the study. Below are in-depth explanations of the main types of probability sampling methods. 1. Simple random sampling. Description: simple random sampling is the most straightforward form of probability sampling, where each member of the population has an equal chance of being selected. Researchers randomly choose participants, often using tools like random number generators or drawing lots to ensure unbiased selection. Steps: define the entire population from which you will draw your sample. Assign a unique number to each individual in the population. Use a random number generator or draw numbers to select participants until reaching the desired sample size. Example: if a school administrator wants to survey 100 students from a school with 1,000 students, they would assign each student a unique number from 1 to 1,000, then use a random number generator to select 100 students. Advantages: reduces selection bias. Ensures each member has an equal probability of being chosen, leading to a more representative sample. Challenges: may be challenging to implement in large or dispersed populations. Requires an up-to-date list of the entire population, which may not always be available. 2. Systematic sampling. Description: in systematic sampling, researchers select participants at regular intervals from a randomly ordered list of the population. This method involves choosing a random starting point and then selecting every nth member on the list. Steps: determine the sampling interval, which is found by dividing the population size by the desired sample size, e.g., if you need 50 participants from 500 people, the interval would be 10. Choose a random starting point in the list. Select every nth individual, e.g., every 10th person, until reaching the sample size. Example: if a researcher wants to survey every 5th person in a list of 500 people, they would start at a randomly selected position and then choose every 5th person after that. Advantages: easy to implement, especially in a well-organized list. Provides a spread-out, evenly spaced sample. Challenges: if the list has a hidden order or periodicity, e.g., seasonal cycles, this could bias the sample. Less effective if the population list isn't randomly ordered. 3. Stratified sampling. Description: stratified sampling is used when researchers want to ensure representation from specific subgroups within a population. The population is divided into distinct strata based on certain characteristics, e.g., age, gender, income level. Researchers then randomly select a sample from each stratum proportionally to the stratum's size within the total population. Steps: identify the characteristics or criteria that define each stratum. Divide the population into strata based on these characteristics. Calculate the sample size for each stratum based on its proportion in the population. Randomly select individuals within each stratum to form the final sample. Example: if a study requires a sample of 200 from a university with 40% undergraduates, 30% master's students, and 30% doctoral students, the researcher would select 80 undergraduates, 60 master's students, and 60 doctoral students randomly from each group. Advantages: ensures representation from each subgroup, which is especially important in diverse populations. Increases the precision and reliability of the results when comparing strata. Challenges: requires detailed information about the population to divide it accurately into strata. More complex and time-consuming than simple random or systematic sampling. 4. Cluster sampling. Description: cluster sampling is ideal when the population is geographically dispersed or too large for simple random sampling. In this method, researchers divide the population into clusters, often based on location or other natural groupings, and then randomly select entire clusters to include in the sample. All members within selected clusters are surveyed, rather than individuals across all clusters. Steps: divide the population into clusters, which could be based on geographic location, school classes, etc. Randomly select a predetermined number of clusters. Survey every individual within the chosen clusters. Example: for a national survey where traveling to each individual is impractical, a researcher might divide the population by city or district, randomly select several cities or districts, and then survey all residents in those areas. Advantages: reduces costs and logistical complexities by focusing on specific, randomly chosen clusters. More practical for large, dispersed populations. Challenges: may increase sampling error if clusters differ significantly from each other, cluster heterogeneity. Results may be less representative if clusters are not carefully chosen. Importance of probability sampling. Each probability sampling method has specific applications and strengths, making it possible for researchers to gather accurate and unbiased data. Using probability sampling allows researchers to draw conclusions and generalize findings about the entire population, enhancing the validity and reliability of the research. By selecting the most appropriate method based on study requirements, researchers can achieve their objectives efficiently, make representative claims, and provide meaningful insights into the research topic.